Welcome to myprojectbazaar.com.
Our product title is low power pulse triggered flip-flop design based on a signal feed through. Let us see about the abstract of our product. Generally, the flip-flops and latches are used as data storage elements. Such data storage can be used for storage of state, and such a circuit is described as sequential logic. Flip-flops can be either symbol, transparent or opaque, or clocked, synchronous or edge-triggered. The symbol ones are commonly clocked latches. The word latch is mainly used for storage elements, which clocked devices are described as flip-flops. A latch is level sensitive, whereas a flip-flop is edge sensitive. That is, when a latch is enabled, it becomes transparent, while a flip-flop's output only changes on a single type, positive going or negative going of clock edge. A flip-flop or latch is a circuit that has two stable states and can be used to store state information. A flip-flop is a bistable multi-vibrator when used in a finite state machine. The output and the next state depends not only on its current input but also on its current state and hence previous inputs. It can also be used for counting of pulses and for synchronizing variably timed input signals to some reference timing signals. The circuit can be made to change state by signal applied to one or more control inputs and will have one or two outputs. Simple flip-flops can be built around a pair of cross-coupled inverting elements. Vacuum tubes, bipolar transistors, field effect transistor, inverters and inverting logic gates have all been used in practical circuits. In this proposed implementation, design is consists four types of flip-flops such as CPDCO, CTFF and MHLFF, and the proposed design in Tanner EDA design. Let us see about the flow diagram of our product. Initially, start the CMOS design and design the flip-flop design, then the triggering the CMOS design, then find out the value of power consumption, what the result we get from the T-space window and the WAD window, and finally the test the results. So in that, our proposed flip-flop design is based on CMOS technology. In CMOS technology, both NMOS and PMOS performs together. A swap is a derivative in which two counter terminal exchange their current voltage flows of one MOS terminal with other MOS terminal. Specifically, two ends are agreed to share one stream of source voltage current against another stream. These streams are called the legs of the swap. The swap defines the time to the flows of source to be completed. The MOS is swapped for exchange of transmission and the CMOS is applied to the designed D flip-flop. Then the signal feed is applied to the D flip-flop. This feedback supplies provides an NMOS terminal of designed D flip-flops. As the result, the power consumption will be reduced to the proposed design of flip-flops and focused on data transition to reduce the delay time. Clocked devices are especially designed for synchronous systems. Such designs ignore three inputs except at the transition of the dedicated clock signal, that is known as clocking, pulsing or stopping. So clocking causes the flip-flop to either change or retain its output signal based upon the values of the input signals at the transition. Next we see about the running process of our product. In this proposed implementation is done in Tanner EDA tool and using of CMOS technology. In the CMOS technology only we using PMOS and NMOS FETs. Using of that we arranging the circuits using of given base paper. So in this process we using four kinds of process. One is the CD flip-flop and EPDCO flip-flop and modified HLF flip-flop and proposed flip-flop design, and those flip-flop designs are designed for the given base paper. And then the first open the SEdit window, then open the cell, new cell. In the new cell we assign whatever we record the data name that is assigned. Then we open the setup simulation. In the setup simulation two kind of things we did. One is the transient analysis. We assign the transient analysis, then corresponding output will be displayed, and then we include the library path, which location you choose for creating the file. So after that we click the run icon, the output will be displayed in the corresponding scopes. First the T-space window will be open. In the T-space window they show the delay and also the overall timing to take the simulation run. So overhead time is shown and also total time is 2.317. The delay is 3.0310. e power minus 10. So this is the design summary. So next one is the WEdit window. In the WEdit window, we use it to see the waveform and also to take the snapshot for that. And first one is the power consumption value of EPDCOFF. Using of this window, we can measure the power consumption. For example, in this power consumption is around 70 microwatts. So we choose the horizontal view, click that minimum and maximum position, then the value power consumption will be calculated. And if you want to see the FFT analysis, then click the FFT, the corresponding frequency value will be displayed. Here the frequency range is 500 megahertz. And next one is the output of the input and output data. So here we can see the output of the data, what data will be given and corresponding output will be shown. And also in the Q bar, the inverting output will be displayed in this process. So corresponding FFT analysis also measured using click that the corresponding output of the FFT will be frequency range will be shown 500 megahertz. So using of EPDCO is the best compared to the other flip-flop types. Because of that, the power consumption and time delay and the output efficiency will be high. Thank you for watching this video.